Hello and welcome to Composite Functions Part 1. Before we even start this, I'm just going to refresh your memory as to how we understand a mathematical function to work. You take some sort of an input number, you pick some sort of a number, so let's say the input is A, and then we plug it into a mathematical machine, and usually we name the machine F. I'm not really sure. I guess because it's for function or something. Anyway, so we take this machine, then this machine does something. It churns the number around, and then it spits out an output, which I'll just call B. Okay, so that's the idea of the input and output of a mathematical function. Now this input over here doesn't have to be a number. What if it was something a little bit more complicated? So let me just actually give you an example here. Let's say the function looks something like, say f of x here was, maybe we double x and then add 1. Okay? Now let's say I'm going to, instead of just putting a number into this, I'm going to put in something like, I'm going to take x squared, and I'm going to plug that in to this function. Okay, what is it going to spit out? Well, what it's basically saying is we're now going to do this. We're plugging in, instead of just x, we're putting in x squared. Okay, and here, this is how the machinery works. It just says, well, you take your input and you times it by 2, and then you add 1. So I go, well, my input over here is x squared. So I guess I'm going to take my input, times it by 2, and then add 1. That's what the machinery tells me to do. And guess what? That's all I can do. I can't simplify that any further. That's my output. Okay? Now I can complicate it a little bit more. What if we had something like, we're going to take x plus 3, and we're going to plug that in to the function. So, okay, let's plug in x plus 3. Okay, no big deal. So what are we going to do? Well, it says here you take your input and times it by 2. So take your input, which is x plus 3, times that by 2, and then add 1. Okay, now this one I can do a little bit of simplifying because I can expand the brackets. So I get 2x plus 6 plus 1. So hey, I think I can see what my output is going to be. It's going to be 2x plus 7. Okay. Now, what we've been doing is we've been putting these things in as inputs. Essentially, we're taking other functions and we're plugging them into this function. So you could think of it this way. What if I just called this guy here g of x? Now, what if I just said, let g of x be the function x plus 3? So what I'm actually doing here is I'm looking at f of g of x. I'm letting g of x be the input into function f. So everything I've done here has treated g of x as the input. I went 2 times g of x, and then I added 1. And I was able to simplify that into this result. Okay? Now this is what we call a composite function. It is when a function acts as the input into another function. Okay? Now let me just show you, I ran out of room here, but let me just show you another way that this is often written. Okay? Often it's written like this. I prefer to see it written like this. Just because to me that's so nice and clear. It says, yes, the input is g, function g, into function f. But sometimes it's written like this, f of g of x. Okay. Just to be aware of that. That's just another way of writing it. Sometimes even you'll see it written with extra brackets around the f of g. And then they have the x on the outside. So just be aware that this sort of, it's like a big circle, but it's not like a degree symbol and it's not multiplication. It kind of reads f of, I guess the best translation is the word of, f of g of x. Usually when it's written in this form, I immediately put it back into what I think is the best way to write it. So I think that's just, to me, it's easier. So let's do an example here, show you how these composite functions might look. Let's say you had something like one of the functions. So let's use, I don't know, function p or something, and we use function q just to get away from the f and the g. Let's say function p was x minus 2, and function q was something like 4x. Okay, nice, simple, happy little functions. Somebody comes along and says, I want to figure out what is p of q of x. Okay, no problem. First thing I'm going to do is I'm going to rewrite that the way I like it, where it went to me the more clear method. P of q of x. Okay, so now I know very clearly this is calling on function p, and the input is q of x. Now, a lot of students like to do this. They switch it out and say, well, what is q of x? Well, q of x is just 4x. Why don't we just put that in there? And then they're not cluttered with so many different letters. So you go, okay, yes, that 4x acts as the input into function p. Now, function p says you take your input and you minus 2. Okay, whatever the input is. You know, sometimes it's easier to think of it this way, just a box. And that box represents what your input is. So it's your input minus 2. So what am I going to do? My input is 4x, so this is going to be 4x minus 2. And guess what? I'm done. I can't simplify this any further, so this is this new composite function. And if I wanted to, I could plug numbers in. I could do all kinds of stuff with it. You know, for example, what if somebody said, we would like you to figure out p of q of 3 or something. Okay. Well, I have two ways I can do this. I mean, I've already gone to the trouble of simplifying it, so now I could just go ahead and say, well, let's plug in an x value of 3 and see what the answer is. It's 12 minus 2. Oh, it looks like it's 10. Now, if I didn't already have this guy sitting here, all right, which made it easier to just plug in the 3, I could also have proceeded in this way. P of q of 3, and then said, let's work out what is q of 3. Okay, so let's just do that first. We'll do that on the sidelines here. Q of 3, what is that? Well, that's function q. Q of x here, it says 4x. So my x value is 3, so this would be 4 times 3. Okay, so that's 12. All right, so now I'm going to go and put that in here, because q of 3 has a value of 12. Now I can just go, oh, so I'm plugging 12 into function p. So function p says, take your input and minus 2. So take my input and minus 2, and guess what? I get the same thing. Okay. Which method should I use? If I didn't have this sitting here already and figured out what the composite function is, then I probably would have gone straight into this method. Why do twice the work? Anyway, that's where I'm going to stop for now with our first look at composite functions. There's quite a bit more, so hold on to your hat.